Okay, here we go. Here. Have you guys ever been to Tuttle's Orchard?
It's by my house.
Is it? Did you ever go to Travel Town and go down those big tube slides down that big hill? Okay, well that's how I spent my whole Saturday afternoon. We would slide down. He would say, "Hey, again." No, we would go slide down. I am so bruised on my backside here, I can hardly move. He wants to go back. I don't know.
Just take a field trip as the class today.
As a class, they do that in grade schools.
I did.
All right, so here we go. Directions say, find all of the zeros exact. We know, or should know, that the word exact means no calculator. Okay, so I'm doing this with no calculator so that we get answers like, if we get root 7, we get root 7. It's not a decimal, no answers. We're going to find, or no rounded off answers. We're going to find all the zeros of this. So, I know it's been a few days, but think back.
1, 2, 4, 8.
What?
1, 2, 4, and 8.
Okay, so we're going to start guessing numbers, and the numbers that we guess, is that a uniform thing you're wearing? Okay, that's not uniform. It's so cool and you look so handsome, but it's not uniform. So, yep, and our lanyard needs to go around our neck. Eli, put it on, take it off.
Come on, Eli, lock in, bro. I'm sorry. We're waiting
So-
on this like this now.
That's right. So PRRs, these are our possible guesses. We are going to have to guess numbers that give us a remainder of 0 because those numbers will be the zeros, the answer to the question, right? So somebody said, Jake I think said 8, 4, 2, and 1. Don't forget, over 1. So factors of 8 over factors of 1. Okay? Now if you don't write this 1 down, I'm okay with that, but understand that 1 is there so that when this is a 2 or a 3 or something, you're going to have it down there. Okay, so let's start guessing. What do you think? What might work? I'm going to try 2. 2 seems to always work. I don't know. It doesn't always work. There's no rule that says 2 always works. I'm just going based on our experience. This does not look good. I guess my theory is wrong because that didn't work, right? So
4 works.
4 works. This is so much easier when we do it as a group. It surely does. Nice job. Nice job. So what does that mean in terms of zeros? It means one of my answers is 4. Okay, now where do we go from here? Well, let's examine what's left. What's left here? X cubed plus x squared minus 2x minus 2. And the remainder is 0, right? Good, that's the goal. Look at that for a second. Do you notice anything about it?
Does it have a, what's it called?
Oh.
We could actually factor this by grouping. Now, if you don't notice that, it's okay. But if you don't notice, you're going to have to guess again, right? you're going to have to guess again. Now your PRRs would only be 2 and 1 for that problem, but you have to guess again. This does factor by grouping, so I'm going to go ahead and do that. Does everybody remember how that works? Remember, when you take out an x squared and you're left with x plus 1, take out a negative 2 and you're left with x plus 1. For factoring by grouping to work, these must match. They do. And then I have x squared minus 2. Now, does that give me other answers? Remember, we had the 4 we guessed. Now, what else do we have? X equals negative 1. And then x squared minus 2, if you set that equal to 0, what does x equal? Plus or minus the square root of 2. Because when you take the square root, remember, you have to do plus or minus. Another thing that might trigger that plus or minus when you do it is, how many answers does this problem have to have? 4. So it can't have just 3. You got 4 now, right? Was that plus or minus? We have 4. Everybody okay with that one? It's a little bit bigger, harder problem. Okay. Now, these next couple talk about upper and lower bounds. First of all, would you just do the division in this problem? So just put 3 in the box, because that's the number in the problem, and then do the division. And I want you to look at the result that you get, the quotient down here. We aren't expecting a 0. That isn't what is probably going to happen. Is that what you got down there? Okay, so we know for sure 3 isn't a factor because we didn't get a remainder of 0. But the directions say 3 is an upper bound of the roots. Now what that means is, if we list out all of our PRRs, let's say this number here, instead of being negative 2, let's say that had been a negative 12. Now it wasn't, but that really wouldn't change anything. In terms of the problem. But if it were a negative 12, then wouldn't your PRRs be that? Okay, now here's the deal. In that list, you have 3, 4, 6, 12. There are lots of numbers in that list that are bigger than 3. If 3 is an upper bound, then I'm not going to guess these numbers. 3 is an upper bound. There are no answers bigger than 3. That's what that means. There are no answers bigger than 3. And I know that because this row, my quotient row, is all positive. When your quotient row, when you do the division, and you get all positive results, or 0. You get no negative numbers. Then you have found an upper bound. So let's think about this. If I know 3 is an upper bound, then I am not going to try any of the numbers bigger than 3. This can be a time saver for you. Don't try any numbers bigger than 3 when you're guessing. So how do I know when I found one? This one's not. 4 is not an upper bound. How's come? Because I've got a negative thrown in there. All right. Now, how do I know when I have a lower bound? Well, let's do this division and see what happens. Seems like I could have picked better numbers than this. I have no idea, I did that without a calculator, so that arithmetic could be off. Anybody else get those numbers? Look at those numbers. You match, or did you just copy them? You match? What do you notice about these numbers? They alternate. When the signs alternate like this, see positive, negative, you have found the lower bound. So what that means is, don't guess any numbers less than -4. Don't guess any numbers less than -4.
So just when they alternate like that?
When they alternate. So if they're all positive, then your number is an upper bound. Don't pick any numbers bigger than it. And if they alternate, you find a lower bound. Don't pick any numbers less than it.
Can it be like negative, positive, like can it start with a
Yeah.
negative?
They alternate, yep. And anytime a 0 shows up, you just don't count it because 0 is unsigned. 0 isn't positive or negative. So if a 0 shows up here, it's fine, just ignore it. If a 0 shows up here, just ignore it. Because they're not, when we're talking about SIGNs, they're not positive or negative. So zeros disregard if the 0 shows up. So if you divided and you got this would not be a lower bound because they're not alternating. See how they're not alternating?
So it just means like nothing
That's not
special?
bound at all. Yeah, it's just a number. Doesn't help you out, you're just gonna have to keep guessing. Okay, so I'm thinking about test day, I'm thinking about how to do one of these problems, I'm thinking about having to guess. So what do I have to help me? What are some tools I have to help me guess? I have my PRR rule, right? That narrows it down for me. And then now I've talked about bounds. So if I happen to choose a number and divide it in, and everything's positive, then don't choose a number bigger than that. If you divide it in and the signs alternate, then don't choose a number less than that on your next guess. Okay? All right. So that finishes 2-4, which will be due on Monday. Feel free to get that done and turned in before if you wish, or you can turn it in on Monday. All right, now 2.5. Here we go.
Should we still turn it in if we don't have to do this though?
If you don't have
Oh,
school
you have to do
Wednesday,
Monday?
do Monday first.
My bad, that's on me. It's on me.
All right, so here we go. Had me a little bit confused. Here we go. Okay, so use the given zeros. If somebody told me that one of the zeros of this thing is 2, and I'm supposed to find the other ones. How many other zeros are there? 2? Remember, when we say zeros, we're talking about when you graph it, they're the x-intercepts, right? So this problem has 3, and we know one of them already. It's handed it to you. You didn't have to guess it, nothing. They just tell you it's 2. So what do you think we should do to find the other one? Which is what?
What's that called? Long division?
Synthetic division? I would have, could I do long division? I could go ahead, I'm not going to, I'm gonna do synthetically. But here's the deal, guys. If I handed you this problem, and said, find the zeros, wouldn't you do the PRRs and start guessing? And when you guess, you do the division, right? Well, they're telling you, this one works. This is your first guess. It works. They're telling me that. You don't have to guess it. They're giving it to you. So you're gonna divide it out. Now you better get 0, which we did. Cause if it's a 0, you will get 0 when you divide. Where do we go from here?
Like, so it's like x squared minus 4x plus 3.
Yep, which we can either use the quadratic formula or factor. So what are your other
3 and 1.
2 zeros? 3 and 1. So, Charlie, you got this day's looking right. This is really an easier version of what we've been doing because you don't have to guess. Divide that number out and solve what's left. That's it, we're done. We found them all. Look at the next one, boys and girls. This is not good because the one they give me is imaginary. So I'm going to divide it out. I'm going to drop down my 1. And I'm going to multiply this times 1. So that's just going to be 1 plus I. Now I add, right? So what do I get when I add here? Negative 1 plus I. Now I have to multiply. And some of you maybe can multiply that in your head. I can't, so over to the side, I am gonna multiply these two together, so because that would be my next step, right? This times this. So I'm just gonna FOIL. What's that equal? Negative 2. So that'll be negative 3. Now I have to multiply again, so that's going to be negative 3 minus 3i. When I take this times this. And when I add, I get 3 minus 3i. Would you agree with that? So now I have to do 1 plus I times 3 minus 3i. So I'm just FOILing. It's easier when I can do it in my head, but I can't. Is that 6? Lord, I hope so, because wasn't this supposed to be a 0?
Yes.
So I better end up with no remainder when I'm done over here? Perfect. What a mess this is.
Yeah, I can write that.
You don't. Remember, in the beginning, it was x to the 4th, right? So this is still x cubed. It's certainly not. I mean, it's a disaster. So, new piece of information. Imaginary roots, roots with i's in them, never occur alone. They always come with their conjugate. So the minute I was told 1 plus I is a root, I know 1 minus I is a root. They always come together. So I knew 1 plus I, so I went ahead and divided it out. Now I'm gonna take this mess that I have left, and I'm gonna divide 1 minus I out of it. So here we go. Wait a second. What's gonna happen here? So it's 0, right? Oh, that's nice. What's left? What's this? X squared minus 3. And now I need to solve that. So what are my last 2 roots then? Plus or minus the square root of 3. So, they gave me this root. The other ones were 1 minus I and plus or minus root 3. 4 altogether. The one they gave me to start, its conjugate automatically, and then the 2 I got when I factored. We knew that one to start, but that certainly is one of the zeros. No question about it.
I have a question.
Yep.
Why did you divide the 1 minus I on the second part?
Well, I knew this one was root, so I divided it out. But if that's a root, the conjugate is automatically a root. So if 2 plus 3i is a root, so is 2 minus 3i. If negative 7 plus I, you also negative 7 minus I automatically. So my job was to find the other zeros. So I knew this would be one of them. So I got it out, and that got rid of all the i's, and then I have the other 2 answers. Okay? So there's 4 altogether. The one they gave me, the conjugate of that one, and then these 2 that
When do you, I'm like a little lost with why you divided again by the conjugate. That's only when you have a plus I.
No. Whoa, no. Remember, this original problem was x to the 4th. So when I divided out, I got an x cubed. How do I do an x cubed? Well, I either guess another number, or I try to factor by grouping. Well, this was what I had left. This was a mess. Somebody even said, how do you even write that? Well, you don't need to write it. You need to guess another number so that it will get down to where it is a...
Are you just like breaking it down into more?
Yep, you have to. You have to. Because you're gonna find 4 answers altogether. Okay? So this is what I have. This is like my x cubed thing right here. But I have to break that down, so I guessed again, except I didn't have to guess, because I knew the conjugate would be 1 to divide it. And it gave me a remainder of 0, just like I hoped it would. That works up an appetite, doesn't it?
Oh, yeah.
Okay. So, let's go to lunch. And have you back at 48, people. We're back at 48. 48.
hear that?
48. Jay